Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, I'm glad to see you here. Thank you for joining my presentation today. I'm Sulidar Fitri and you can call me Fitri. In this occasion, I would like to present our research paper. The title is Activity Recognition or AR to detect dementia using Wi-Fi based wireless sensor network with received signal strength indicator or RSSI method. Here are my team as the authors. First author Hani Rubiani, second author Eddy Samsoleh, and the last one is I am myself. We are from Universitas Muhammadiyah, Tasikmalaya. This presentation is provided to participate in the event of International Conference, Science and Technology, Engineering and Industrial Revolution 2021. Well, coming to our introduction as the background here, the increasing of number for elderly people, or it is said that they have entered a period of aging population. We can see here from the graph, especially for Indonesian graph, there's two kinds of color, black and blue, which is black is predict from 2015 and the prediction until 2030. Here we can say about 5 million people will grow as elder people. So, why this is so important? Why we have to concern about the elder people here? Because the elderly is susceptible to dementia. So, what is dementia? Uh, from the book reference written by Lee, the title is Home and Health. Dementia is a brain disease syndrome that occurs primarily in case of older people. In a broad sense, the brain dysfunction has a distinct relation to cognitive disability. So, the symptom of dementia may include repetition of simple actions such as wandering at outside or wandering inside the house, collecting objects, asking the same question repeatedly, becoming lost in familiar places, being unable to talk or read or write, and etc. So, such symptoms can be detected by an activity recognition or AR systems. AR in daily life for the elderly must be done indirectly and in a comfortable way without disturbing the daily activities of the elderly. Next, this is kind of the objective for this paper. In this study, a Wi-Fi based indoor positioning system will use the signal strengths of several access points recorded in the room inside the house. The results of recording when it receives signal strength indication or RSSI is to digitize the behavior elderly in their daily activities that can be tracked individually. And by this paper, this research also explaining the modeling method by using k-nearest neighbor for elderly observation data and the random waypoint modeling method, or we can call it RWP, to detect dementia symptoms. Now, here are the terms that we need to consider from this research. First, RSSI, or the full name is Received Signal Strength Indicator, is a measurement how well your device can hear a signal from an access point or router. It's a value that is useful for determining if you have enough signal to get a good wireless connection. Then, about the AR, or Activity Recognition Systems. It is a large field of research and development currently with a focus on advanced machine learning algorithms, innovations in the fields of hardware architecture, and on decreasing the cost of monitoring while increasing safety. Also about human activity recognition, or HIR. has been widely used in previous research and has value both in theory and practice in solving problems related to time series. These studies include in smart home, human-computer interaction, and health monitoring. And about the RWP or random waypoint here, this is about the modeling methods using for the mobility, so we can track the mobilization of some people. Well, okay, on this slide we can see about the human activity recognition. There are several stages that has been through for recording the dysfunction activity from the elderly. The first stage is activity signal. The activity signals we can provide by Wi-Fi signal, and then we need the elder to wear the cell phone or bring the cell phone or maybe wearing the watch, glasses or shoes, and then we provide also the signal maybe from GPS, Bluetooth, or sound, and then Wi-Fi. So based on the connection about the signal to the device, we can record the strength of the signal. Next, go to the signal parameters as suggestions. Here, we can see from the table 1, Wi-Fi signal strength parameters. And here it categorized by 5 level of signal bar. And this is a category that categorized from very bad to excellent category. So, in each level, it has the value of signal strength in dBm units, or we can say it as a decibel milliwatt. So the value is start from lower than minus 90 until higher than minus 60. So this parameters is very useful to record what kind of signal, how the strength of the signal that emit from some of access points. And next is about location tracking algorithm. Here, when we already caught the signal and record the value of the signal, we need locating the tracking algorithm to creating the model. In this case, for this research, we use the KNN, nearest neighbor algorithm, to calculate the distance between the data and the objects. It means that we calculated based on the Euclidean distance in KNN, nearest neighbor. Here are the formula that's already stated. D means distance for Euclidean, and also there is square root of sum from 1 until p to object, and then object minus the distance or the points of reference in some access point. So next, talking about the mobility model, here we use the random waypoint or RWP model. So we need to calculate about the how's the track the points for the mobilization as a mobility. What we need here from the speed minimum until speed max as the interval, then we calculate. From each node, also we calculate according to the predetermined pause time before moving back to using the same procedure. So, as we know, RWP or WP is a mobility model that has a movement pattern that tends to gather in one simulation area so that it can cause a density wave to occur. In the RWP model, the nodes are randomly distributed in the net. Coming to the methodology and design, we construct about the methodology here first is for the preparation of research site. So at this stage, we need to make the site plan for the house from that elder people, especially in this case, we ask one person as the elder person. The age is 85 years old, and she is old enough, and she is female. So we need to creating the draft, also the drawing about the site plan about her house. And the next stage is the methodology. Here is the determination of location by received signal strength indicator, or SSI. How to determine the signal strength location? Here we doing some steps. For the first, the data collections, RSS visualization. We need to visualize what kind of data that we are collected. Then cross-validation data training. After we getting the data, and then we need to do some training by using the validation. Cross-validation data training. And then next, positioning, measuring, data testing, and then algorithm modeling. And the last is we can record the activity recognition. Well, for the site plan, here we can see there are several rooms, and the main room become the elder room is in the bedroom 4, and later on would like to observe what kind of movement or activity that she already did. Was she wandering around the house into every room or every side in that house, or just several compartment of room? And here for the data collection here we need to put on the point reference. Well, next about the net surveyor here. This is one application, one software that we used to collect the data from the signal strength. And here we can see several bar. We see 4 bars here. Actually, these bars, each bar indicate that it shows us that there are 4 access points that are recorded by the software. Actually, the access point in internal access point here, not all belongs to the elder, belongs to the landlord, but 2 of them are got from another Wi-Fi in outside the house. So this is the picture about the application or the software that help to record the signal strength. Next, the visualization of RSSI. Here are the some of visualization signal strengths that caught by the software. There are several colors from blue to red. The blue one is the strength signal and the red is the minimum signal. At 4 points here, because the 4 access points that got from outside. Now going to the next slide. Next stage for methodology and design here is positioning. In the step of positioning, we measure the data testing. Why we need data testing? Because we need some model into modeling algorithm. So this data is the first data for the test location. So we try to do some testing area. We record the signal strength, and then later on we will put it into the modeling algorithm. For the result and discussions here, after imputing some data in the modeling algorithm by K and or K nearest neighbor, we got several results here from the past, because first we use the tenfold cross validation. It will start from the K equal 1 are shown on the picture, that the accuracy here produced 75.73% for K equal 1. And when we try to use K2 until 10, the result not as better as the K equal 1. So that K1 is the best accuracy that record from the software. Then here are the lists from the table about the accuracy. Start from k equal 1 to k equal 10. So based on this data, we can see that the best accuracy gotten from the k equal 1 is about 75.73%. For k equal 1 to k equal 10, so the graph will shown as the picture. Then beside that, we also have the minimum average error distance result. And here the results told that from the results k equal 1 to 10, it shows that the minimum error distance is at k equal 1, k equal 2, and k equal 3 with the same result, which is 0.298 meters. For this reason, the location prediction used is determined, namely k equal 1. And next, going to the object tracking location, after we did the research, after we did practicing how we record the signal strength here, we can see here that some track from the object. And the result for the time graph here, based on the time graph here, we can see there are color blue, maybe dark blue. Here, most of the time, the elder still spend most of the time in the bedroom too. And sometimes she go wandering and around the another rooms, another compartment of the house, another part. There are such a bathroom, 1, 2, washing area, wardrobe, outdoor kitchens. And she's still wandering until one day, and these are the time graph that already shown. Even though the most time spent in the bedroom too was actually the same much time also spent to another rooms in the house. After we figure out the mobility object, we can capture the pattern as shown on this figure. The size of the point is determined by the length of time living in the area during the observation period, namely the total time of 24 hours. In whole day, one day, by using RWP, we can capture the pattern about the elder activity here. And next, the result of RWP here. The parameters for normal human movement is between 0.53 until 1.81. So, when the A total is in between 0.53 and 1.81, it means that this person is still normal and not indicate a suspect of dementia. But beyond this value, there is different pattern of movement with dementia who go to more locations than in normal cases. By this result, we can see that the result total for A total here got the number of 3.139. So it means this number in total exceed the number of 1.81, which is there still parameter for the normal case, and apparently the result of this case is observed more than 3.139, so it means that uh, there is such a suspect dementia symptoms that happens in this elder. Well, now we arrive to the last section of our research paper. Here is conclusion. And I try to explain that the conclusions here are: first, the results of tracking objects within 24 hours means that this is we've done it from all day in one day, show that the object or the elderly is in several rooms within a certain period of time. The longest time spent is in bedroom 2 and several other spaces. In this case, the object experiences such a thing as wandering. In the case of the object being observed, an elderly person aged 85 years from modeling using RWP here got a total value of 3.139, which exceeds the normal case, which is more than 1.81, because the normal boundary is only until 1.81, but the value we got here more than that number, so 3.139 is exceeded the normal criterion number. And the last conclusion is, so in this case shows that the person has dementia symptoms. Well, before I close this presentation, I'd like to give acknowledgement from several parties. First, to Department of Electrical Engineering here. Thank you for the support, and also thank you for the Faculty of Engineering Universitas Muhammadiyah Tasikmalaya. Then for LPPM, thank you so much also for Universitas Muhammadiyah Tasikmalaya. Because of all your support, we can finally hear and present our results, research. So, everyone, thank you for attention, and thank you for following this presentation until the end, and I hope to see you again next and soon. So here are our last session. Thank you all. Maybe I see you again in another occasion. Bye bye. Wassalamualaikum warahmatullahi